So rates are a good one to know, and I have a visitor here. So rates are a good one to know because they're something that often gets ignored or not really talked about correctly when people are talking about statistics. So one of these things you should be on the lookout for are any sort of statistics that ignore the denominator or ignore the number of people that's producing some statistic that's a count. And for this, I want you to think about this question. How is this possible? There are almost twice as many youth suicides in 2010 as there were in 1980. But the suicide rate stayed about the same from 1980 to 2010. That first one's really alarming, right? There was definitely some sort of crazy epidemic of youth suicide that swept through the nation between 1980 and 2010. But hold on, the rate's been about the same. And the answer is that the number of youths in the country changed. So because of generations, sometimes there are more young people at different times than there are at others. And what happened was that due to a fluke in how many young people there are in the country at the time, there were way more youths in 2010 than there were in 1980. So even though the rate of suicide or the number of suicides per, say, 100,000 youths stayed about the same, the total number of suicides increased because there was a larger population producing them. Just like if you were looking at crime rate, you'd expect to see more crimes in a larger city. But again, you might see that first statistic reported, there's twice as many suicides, and be really alarmed. So if you ever see something like that, it's a good idea to look at the rate that the numbers are coming from, because otherwise the statistic might be misleading. All right, so we're finally into our last segment of this week, which is visualizing data. And this just means graphs. And for graphs in this course, I'm going to take you through a tour of them. I want you to be able to recognize them, but I'm not going to ask you to do too much in terms of making them, especially since this is an online course and I can't ask you to draw something on a piece of paper. But graphs are really, really useful for visualizing data. And we're going to talk about a couple of different kinds of graphs that you can use for variables that are at different levels of measurement. The first one is pie charts. Pie charts are only good for variables that are at a nominal level of measurement. In other words, that have attributes that can't be put in order. And a pie chart can be described as a circular graph with pieces that add up to 100%. So there's fun examples of pie charts. Things that make the rock and roll go round. Fat bottom girls and blue-eyed floozies. Well, as we all know from Queen, fat bottom girls make the rock and roll go round, so 100% of the pie chart is for that. This is another pie chart that I like. This one is my life broken down into segments, and the segments are sleeping, working, eating, and unfortunately covered by my head, looking for things I just had a minute ago. That's at least my life. Another one is a pie chart made of an actual pie, which shows a proportion for pie I have eaten and pie I have not yet eaten. So these are goofy examples, and on the next slide I'm going to go through some examples from our class data where you can see it with some actual numbers. So one of my favorite things to ask all you guys are what things you would do for different amounts of money. And these questions are based on questions used in moral psychology to get at people's sense of values and the kinds of things that they consider acceptable and not acceptable, but they're also just really fun. So one thing I asked was, how much money would it take for you to insult a stranger, or would you not ever do it? And in our class, 43% of you said that you would not insult a stranger for any amount of money, whereas 50% of us could be bought here. And so what you can see is that the pie chart is a circular graph. We have slices of the pie for would insult a stranger and would not insult a stranger, and they correspond to the percentage of students in the class who would do either of those things. Would you eat an entire cake in one sitting? Well, in this case, 83% of the class would be willing to eat an entire cake in one sitting, given some amount of money, whereas 17% of you would not do this for any amount of money. I could say, here's $5 billion, eat this cake, you'd be like, nope. Which I think is great. Would you burn the flag? And this one, again, is one that's sort of drawn from this values research, and I always find this one interesting. We'll look at some of the actual numbers later, but people here are usually either really willing to do it for a small amount of money or not willing to do it at all. It doesn't take a lot of money to get the people who would do it to do it. But we're not going to get into that now. But what you can see here is that we have more than half the class would not ever burn an American flag for any amount of money, so 54%, and 46% of the class would burn an American flag for some amount of money. Finally, a fun one, would you spend a day at a nudist colony? I also intentionally don't explain what you have to be doing at the nudist colony on that day, but in this case, 70% of people said that they would spend a day at a nudist colony for some amount of money, and 30% said that they would not spend a day at a nudist colony for any amount of money. So those are pie charts. Handy for getting a quick kind of visual look at what the data are saying. Okay. Next up, bar graphs. Bar graphs are also useful for quickly showing what the data look like, and they're also for nominal level variables only. So if you can put the categories in order, generally you don't want to use a bar graph, although you will see it sometimes for ordinal level variables. And what bar graphs show are the number of observations in each category on a vertical scale. This means that we have an x-axis that has the different variable values or possible observations that it can have, and a y-axis that has a frequency and sometimes other kinds of counts as well. So you may see that also. And on bar graphs, the bars don't touch each other. This seems like a minor thing, but there is a different kind of graph where the bars do touch each other, and they're used for different variables to show different things. So examples of bar graphs include this silly one for winners of Miss Universe, where your variable would be place that the Miss Universe competition occurs, Earth, or the rest of the universe, and your frequency would be how many times the winner has been from Earth. And as you can see, the winner of Miss Universe is always from Earth. This is another kind of silly one. On the x-axis, we have things to lend to a friend, and on the y-axis, we have a count for how cool it is. So this one wouldn't be a frequency necessarily, but it's an example of a bar graph showing some other kind of count on the y-axis. And as we can see, it's pretty cool to lend your friend a car, a hand, but not so cool to lend your friend a handgun, your spouse, your toothbrush, but then it's pretty cool to lend them a T-Rex costume. So for some more concrete examples, we're going to look at those questions again about what you would and wouldn't do for money. And what you'll see is that the information on this slide is going to be exactly the same as the information on the pie chart slide, it's just a different presentation of it. So, would you insult a stranger for some amount of money? In this class, 26 people would insult a stranger and 20 people would not insult a stranger. These would be the same percentages as you see in the pie chart on the other slide. We're again just looking at them now as counts. And as you'd expect, we have the different possible observations for this variable, would not do it and would do it on the x-axis, and the count or number of people who answered the question in each way on the y-axis. Would you eat an entire cake? 38 people would eat an entire cake if given some amount of money, and 8 people would not ever eat an entire cake for any amount of money. Would you burn the flag? 25 people in the class would burn the flag for some amount of money, and 21 people in the class would not. 25 people would not burn the flag for any amount of money, and 21 people would. And something else to note on these, I just made these graphs in Excel pretty quickly, so I didn't futz with the counts on the y-axis at all. But on the first two graphs I showed you, the counts go from 0 to 30 and 0 to 40. On this last graph here, the count goes from 19 to 26. So it looks like there's a huge difference between the bars, but there really isn't. So this is really something else to be on the lookout for if you're ever out in the world. If the numbers on the y-axis are really close to each other, it makes the difference look really, really dramatic. Because really, there's only a 4-person difference between would and would not on the burn the flag question, but it looks almost as dramatic as the 30-person difference on the eat an entire cake question. So thank you, Excel, for giving me that example. All right, and finally, a day at a nudist colony. 31 people in the class would spend a day at a nudist colony for any amount of money, or some amount of money, and 13 would not spend a day at a nudist colony for any amount of money. All right, moving along. Histograms are similar to bar charts, but they're for a variable that is not nominal level. So if you have ordinal, interval, or ratio data, you can make a histogram. Otherwise, the information that a histogram shows you is really, really similar to what you see on a bar chart. And what histogram shows are the frequencies of values that are consecutive to one another. In other words, values that start from least to most and that you don't have any gaps in between. So on the x-axis in a histogram, the horizontal axis, you see the values that your variable can take on in order from least to most with no gaps. And on the y-axis, you see the frequency with which they appear in your data. And in this case, the bars touch. And the bars touching is supposed to show that the variables are in order, the attributes are in order, and there are no gaps between what you're showing on the graph. And for this one, I'm actually going to hop back over to the document camera and show you how to make one of these bad boys using the data that we already have. And as I said, you're not going to have to make it yourself in this class, but it's helpful to see how what's on a histogram corresponds to the data you actually have, since both frequency distributions and histograms will be showing up again.